All right, everybody. We're going to go ahead and do some problems together. We're going to do some on page 3, page 4, and page 7. Okay. We're going to do a couple, and then you are going to basically complete all the problems on those 3 pages. And then if you finish early, you can go ahead and start your homework for the day. That's the plan. So let's go ahead and talk through some of these problems. The main topics that we're going to be talking about are solving multi-step equations, and then also solving equations where variables are on both sides. Okay, now one of the things we're going to have to be covering is distributing. Okay, so here we have in this problem, we have 27 equals 3x minus 3 times the quantity of 6 minus 2c. Oh, actually, this should probably be both x's. There you go. Okay, so first thing we're going to want to do is distribute this negative 3 into the parentheses. Now let's focus specifically on distributing that negative sign. All right, we have a negative 3, which is going to get distributed each time we multiply. All right, so we have negative 3 times positive 6, which is going to be a negative 18. And then we have a negative 3 times, oh, there it is again, a negative 2x. So negative times a negative is going to be, this time it is positive, so we have a positive 6x. And we're going to bring everything else down. So notice that I didn't drop this negative sign down. All right, we're going to avoid double signs. We're not going to do something like negative 18, bring down this minus sign, and then, do negative 3 times positive 2x. That's not what we do. Okay, the sign here is going to depend on what you get when you multiply the negative 3 and the negative 2. That's why it was positive 6x, so we write plus 6x. All right, so let's keep it going. So we want to go ahead and simplify anything that we have on each side of the equation. So the 27 is all by itself. That's just fine. We have a 3x and we have a positive 6x. So we're going to go ahead and combine these like terms, which is going to get us, so we'll get 27. This is going to get 3x and 6x, both positive, so that's just 9x minus 18. And this should look like any old, two-step equation that we've been working with. So StatMap would tell us we're going to go ahead and deal with our subtraction and addition first. So we'll add 18 to both sides, which will get us 9x on the right, and this will end up being 45. And we could finish this out by dividing by 9 on both sides. And we'll get our final answer of x is equal to 5. All right, so that's our answer for number 2. I'm going to go ahead and talk you through number 4, or brief you on it. But after this, after we talk about number 4, you can go ahead and finish the rest of the ones on this page, numbers, I think 1, 2, 3, and 4. So let's go ahead and talk about number 4 real quick. So the first thing I want to talk about, and actually once I talk about it, or actually right now if you want, you can go ahead and pause the video and go ahead and try this on your own. I have all the work under this, under this shade. But the first thing I want to talk about is asking, can we do 5 minus 2? Like, is that the first thing that we should do in this problem? Or in the 6 minus 3? Is that the first thing that we do? And the answer is no. Okay, that is not the first thing we do. I know it looks appetizing, right? To just do 5 minus 2 and make it a 3, and then look to distribute that. But if we think about PEMDAS right here, right? It says we do parentheses first. Okay, we would look inside these parentheses. Well, there's nothing for us to do because they can't be combined. All right, exponents, multiplication, division, and then we do addition, subtraction. So distributing is part of multiplication, right? So we cannot do this subtraction or addition, whichever. We cannot do that before we multiply. So in other words, we have to go ahead and clear these parentheses out by distributing before we can even consider doing this subtraction. All right, so the first thing we're doing, we're taking this negative 2 and distributing it inward. Again, being very careful with our negative sign. So in this case, negative 2 times 3x gets us a negative 6x, and negative 2 times negative 4 gets us a positive 8. So I'm going to go ahead and scroll down to the next slide. Or next line. Again, I would like for you guys to go ahead and give this a try. So if you haven't paused yet to complete the problem, maybe do that first. So here you go. We did our distributing first. In red, I've marked what was done in the problem. After that, we're going to go ahead and combine any like terms that you have on each side of the equation. That's what it looks like here in this line. All right, so we combine like terms, in this case the 5 and the positive 8. Here, I'm not going to go through the whole thing, but the x's combined, you get negative 2x, and the constants combined to get a positive 3. So right here we have variables on both sides. Okay, so this is actually something we're going to be talking about in just a second, but you can see in this case we add 6x to both sides. If you chose, you could add 2x to both sides. That's fine too. We added 6x to both sides. That's going to leave us with 13 equals 4x plus 3. And once again, we are just at a normal two-step equation. So we can go ahead and subtract 3 from both sides to get our constants onto the left. We're left with 10 is equal to 4x, and we can divide by 4 to get our answer of 2 1/2. All right, 2.5, 2 1/2. Technically, you simplify 10/4 to 5/2, 5/2. Any of these are fine answers. All right, cool. So hopefully you were able to do that one, and you're just kind of checking your work there. All right, once you finish that page, let's go ahead to page 7. Page 7 is all about distributing. Okay, there's a bunch of different problems there. So let me make sure, let's pause this real quick. All right, so I went ahead and I actually added one more problem in here that I wanted to talk about. So first, let's take a look at number 1. So again, this is all just distributing. Okay, so one like this, we can just distribute 3 times x, get 3x. Oh, switch to a marker. 3x, and then we can do 3 times -4, and that's how our sign becomes -12. So 3x minus 12. Once again, don't just drop a sign down. Multiply 3 and -4, and whatever you get, positive or negative, that's what decides what sign is in the middle. All right, let's go ahead and do this one. So we have 3 terms here in the middle, so we're going to go or inside the parentheses, so we'll distribute to all 3 of them. Okay, so this is going to be -5 times x squared, or -5x squared. We have a negative times a negative, that will become a positive 5x, and we have a negative times negative again, which gets us plus 15. Take your time, make sure you get these signs right. All right, this last one is going to have an extra step in there. So let's go ahead and distribute 7 times m, gets us 7m. 7 times -6 gets us -42. We have -8 times m, -8m, and -8 times +1, or -8. All right, so again, if there are any like terms here, we need to combine them. It's probably something we should have asked ourselves at the top, but let's see, on this number 2, x squared, x to the first, and that's just a constant. So no, these second ones could not be combined, but there is stuff we can combine in this second one. So we have m's and we have constants. So let's go ahead and write our final answer. 7m minus 8m gets us a -1m, which I'm just going to write as -m. And then we have -42 minus 8. So that's a negative plus a negative. It's going to get more negative, so that's -50. All right. All right, cool. So you're going to go ahead and finish the odds on page 7. And we're going to go ahead and talk about a couple on page 4 right now. All right, so again, you can go ahead and pause the video if you want to work on that, or you can watch the whole video and then go back and complete all these pages. So here we go on page 4. Let's take a look with variables on both sides. All right, so we actually dealt with one of these with problem number 4 on page 3, I think it was. So we have some options here, right? We want to go ahead and basically look to get all of our variables onto one side, okay? Some people will go ahead and try to move the constants as well. I want you to always, always, always move your variables first. We'll deal with the problem in a little bit that will, kind of point out why that is. But you can go ahead and move whichever one you want. So basically by canceling it out through addition or subtraction. So right here we have a -8x. My tip is to pick the one that's smallest, so -8 is smaller than 4. It'll help you kind of keep things positive. So here we go. We want to go ahead and get rid of a -8x. So I'm going to add 8x. I'm going to do it the same on the other side using the addition property of equality. And just add it to the 4x. So this will cross out. And we are now left with 7 is equal to 12x minus 17. All right, we moved our variables to the right. Let's go ahead and move our constant away from the right and move it to the left. So we'll add 17. And we're left with 24 equals 12x. All right, these look like they're going to be pretty compatible. I'll divide by 12 on both sides. So this just becomes 1x is equal to 2. All right, so there's our answer here. So once again, we're looking to move our variables first, get rid of it from one side, and then do the same thing with your constants. All right, let's take a look at number 3. So we're jumping around a little bit. So for number 3, we're going to distribute on the right. So we have 2 times x gets us 2x, 2 times 5 gets us 10. All right, well, this looks pretty similar on the left and the right. Okay, I'm going to carry through with this problem, but this actually is a good indication already of what's to come. Let's go ahead and move our variables first. So minus 2x minus 2x. All right, those both go away. So 2x minus 2x is just nothing. I'm not going to write a 0. I'll just write 10. And the same thing here. We're just left with 10. All right, so our variables are eliminated. These are special types of problems. When your variables at the end of a problem are completely gone, you just kind of have a statement. So let's go ahead and change slide real quick so we can talk about these. So if your variables have been eliminated, you are going to be left with a true or a false statement. So if your statement is true, such as the one we just had a second ago, 10 equals 10. All right, well, that is in fact true. So what that means is the answer to this problem is all real numbers. Every number will work. It's also known as an identity problem. You'll see that a lot in the textbook. Or it's known as, like, you know, the answer shows the identity property. So we're going to write all real numbers, or the symbol. And what that means is, so in this problem previously, we found that x is 2, meaning that this equation is true when we plug 2 in for x, and only when we plug 2 in. In this problem, it's saying that any number, when plugged into x, it will be true, no matter what. You can plug in 0. So if we put 0 on both sides, you put 10 on both sides, you put 50, negative 40, whatever. On both sides, it will work. And, you know, that should be pretty apparent by this step right here. It's literally the same thing on both sides, okay? If you get a false statement, so at the end, variables are gone, you have something, and, you know, it's just crazy talk. Negative 10 equals 5, that's obviously not true. This means no solution will work, and this is the symbol for it. So the answer would be no solution. All right, let's go ahead and take a look. I think I have 2 more for us. Yes, I do. So this is number 4 on that page 4. Feel free, you can solve it on your own and then, you know, unpause the video to, you know, see me do it. So we'll have 3x is equal to 3x plus 12. All right, let's move our variables to one side. All right, once again, they are eliminated. Okay, so there's nothing left over here. Okay, last time I told you we weren't going to write a 0 over here when we did 2x minus 2x. Here we are, because there's nothing left. All right, so we're just going to write 0 is equal to, don't need the 0 here, we just have a 12 remaining. All right, so here's that nonsense talk that we were talking about. 0, in fact, does not equal 12, so we're going to go ahead and write no solution. All right, no solution will work here for x. And the symbol we can write as well, like this. Okay, we'll write all real numbers here. All real numbers. All right, cool. So that is number 4. Let's take a look at our last one I want to do together, and then, like I said, you'll finish the page. This is number 6. So 5x plus 4 is equal to negative x plus 4. All right, so my request, my advice, you know, whatever, is that I want you to move variables first, okay? Always. I want you to move variables first. So either pick this 5x to get rid of and move it to the other side, or pick this negative x and move it to the other side, okay? I don't want you to move the 4s. I'll talk about it in a second. So again, I recommended moving the smaller one. So let's go ahead and get rid of this negative x, also known as a negative 1x. So we can go ahead and add 1x to both sides. This will cross out. This becomes 6x plus 4 equals 4. And then from here, we'll subtract 4. Again, we're back onto that 2-step equation. All right, this is going to be now just 6x is equal to 0, okay? Because 4 minus 4 is 0. Now, don't stop here. Don't, like, you know, some people get thrown off by the fact that we have a 0 in our problem. Finish the problem until x is truly isolated, okay? We need to get x by itself. So how do we get rid of the 6? Well, it's multiplying right now, so we're going to divide by 6. And what is 0 divided by 6? It's 0. Okay, so 0 is the answer for x. 0 is the only thing you can plug in for x here to make this a true statement. And, you know, if we were to plug this back in mentally, that would make sense, right? 5 times 0 is 0 plus 4, just 4. Negative 1 times 0 is 0 plus 4. Okay, there you go. So the only way that we can go ahead and make this true is by plugging 0 in. So let me talk to you real quick about the reason why I want you to move variables first. So in this example, we're going to go ahead and subtract 4 from both sides. Check it out. Okay, it does seem pretty appetizing, right? People like to, you know, we just cross out because you see a positive 4 on both sides, just cross them out. But look what happens. We end up with 5x equals negative x. Now, a lot of students look at this and they go, oh, well, 5x's can't equal negative 1x. So oftentimes they just say, okay, this is no solution. But that's wrong. Okay, this problem is not done. We have not collected all our variables on one side. So technically, you would have to keep going here. So this would be, let's see, 5x equals negative x. Well, we have to go ahead and add that x onto both sides. It crosses out here, and we're left with 0. And this equals 6x. And then, Okay, we're back to where we were at this stage, where you'll divide by 6 on both sides. Okay, so just that's where my warning comes in. Is it possible to do it this way? Yes. Will students still make mistakes doing it this way? Yes, it's something I see all the time. Okay, so really get in the habit of moving your variables first, and it will help you to avoid this pitfall that I see students get into. All right, so right now you're going to go ahead and work on page, let me write it back in here, page 3, page 7, I believe I said odds, and then page 4. You're going to finish that page, including the word problem. I think it's number 8. And then you can go ahead and start on homework. All right. Have a nice day, everyone. I will see you next class.